Millennium to power millennium. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, March 19, 2022, Saturday 3:51 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक मार्च 19 2022 शनिवार 3:51। Back to you about same episode of quality and coordination engineering projects, reliable engineers, communication concrete, engineering works contracts, safety, health and environment, designs, construction methods, claims, organizations and works quality. All are inclusive issues without which we cannot discuss anything. And this is my email ID, as you can see, Suraj SURAJ underscore ENGINER engineer at yahoo.co.uk, and this is my certifications, valid certifications, and this is my certification evidence of International Professional Engineer India under provisions of International Professional Engineers Agreement applicable world over. And this is C Engineer certification, Chartered Engineer India. This is fellow membership FIE, and this is quality leading file, and this is coordination leading file. Both are clubbed together but separately due to some reason of memory. And this is concrete specification from Japan. I now close this file and also fellow files just to reduce RAM. And we continue with quality and coordination, and also our topics, quality and coordination, which is a significant topic for everybody, for every person, even if you do not work in engineering or if you do not work in profession even. That too, it applies in your work. Whatever work you do, you have to work according to certain requirements, or you can say certain set principles, certain set systems, or certain set procedures. That is, you can say, which come under ambit of quality, and you have to link together something which may be not formally, but that is in your mind, that exists in your mind, how to link sequences and how to move further and how to check previous one, and that you can say is part of coordination. So quality and coordination, of course quantity is there, quantity is included, but quantity itself is not important. We have to produce quantity in firm quality, confirmed quality. Quantity shall be there depending on what product you produce, what work you do. But quality is inbuilt in that requires to be inbuilt, without which you cannot do anything. And that's why I take this topic of quality engineering and coordination engineering for better quantity engineering or project engineering, you can say. Every project has many items and many quantities of that item, which are based on many specifications valid for that project, which specifications are required to be produced and implemented, which we particularly on engineering project works. And in every engineering branch, and those engineers and those workers who carry out this, because a group or a team does it, so those are called a group of reliable engineers along with reliable workers, reliable employees or reliable technicians, and they have to communicate about information whatever is required, which is, you can say, very significant part of work. Better communication means better coordination, and better coordination means better doing job, and by doing implementing better job, this means better quality, and when you say better quality, this means better product. And concrete work, you can say, it's not simply, I say concrete is a material, I'm talking of that, as well as concrete is a state of material, state of product, and that applies everywhere. When you say concrete as a state of work, it applies to every product, and when you say concrete as a material, it applies to concrete only. And civil is that branch of engineering which deals with almost all other engineering, which deals with a kind of, you can say, it's a production engineering for permanent works. Civil engineering is permanent work engineering. It's not temporary work or work for few years. Civil is that engineering which stays with you for generations together. And that's why it's a kind of public engineering, I can say. It's not a branch of engineering, but it's a domain of whole world. Civil engineering which supports all other engineering, and that's an important point. That's the beauty of how to consider that. When you are born somewhere in civil engineering product, and when you die, one dies also in civil engineering product. That point to keep in mind means from birth to death, civil engineering comes into play. And we have to, because we have to deal with civil engineering and civil and engineering, then engineering is almost general term, but when it's civil engineering, it's actually for all. Public engineering, world engineering, nation engineering. And then civil engineering means it has got many relations to contracts, and not only civil engineering, all other branches of engineering have got contracts into this to every domain. And contracts means work contract or supplies contract, or you can say services contract. And all contracts means workers are there always, human resources applies there, machine resources apply there, services apply there. So we can say when human resources are applied there, machines are applied there, safety, health and environment must apply there. Without safety we cannot allow workers. We have to keep workers safe, we have to keep machines safe. We have to take care of environment as well, because environment is very important part of life. How you can breathe good, how can we walk good, how can we stay good, healthy. And that's an important point. If workers are not healthy, I can't get work done. Workers are equally important as technologists are, engineers are, owners are. Workers, if don't work, who shall work? That's point of view. And if who shall work, you cannot say that this is a digital world and we don't depend upon workers. That is foolishness to say that. Even if you digitalize world, workers will be required. So safety, health and environment is that branch here which is automatically understood when we talk of quality, we talk of coordination. Somewhere safety of human employees and engineers come into play. Safety of everyone comes into play, and that's what designs and construction methods we evolve. And without designs, no engineering can be done, and without construction methods, no work can be done. Design work and construction work both are interlinked. And because these are linked along with contracts, so claims are also linked. And when claims and designs and constructions are linked, means somebody has to do it. And that's where design organizations, construction organizations are linked. And that's why I say works quality. So this is a kind of practical definition of work, practical definition of, you can say, development, tool of development in all these subjects. There will be many more, but we restrict to many, we restrict to only this. I restrict to particularly leader of subjects in this quality and coordination, because I observe that quality does not work to a level, to a mark it's required, particularly in our country. Same situation exists in other countries also. I cannot say we are number one in this, but okay, let us consider ourselves. It's our duty to improve ourselves. If we don't improve ourselves, this means it's our fault. If we don't improve ourselves, we have to improve ourselves. Our job, our duty. And if I don't improve ourselves, that's my fault, your fault, everybody's fault. We have to think that way. Always it is easy to criticize others, but it is very difficult to criticize oneself. If you criticize oneself, we can solve many problems without any problem, We can solve many problems without interfacing other problems. Self-criticism, self-examination, self-investigation is always reliable. Self-service, just like we say. It's do self-service. You go to a restaurant and they say, okay, self-service is you can avail self-service. And I would say those people who are good, who are professionals, who are intellectuals, they generally try to have self and self. So if you say self quality control, self quality organization, self coordination, well, I think if that works, we can find better approach there. We can find something more and more reliable when we say best quality, best working, and everything is best. That point is really, we can say, very important. We have to think that way. It's not simple. I'm talking of quality and we know about quality. You cannot say I understand everything. I don't want to repeat it every day. I'm not repeating anything. It's requirement. Quality, I'm talking about our country, Bharat, India, that announces, that speaks what is quality and what is coordination, because I consider that we have to learn about quality a lot. Our engineers, they know quality. I don't say they don't know quality, but they do not concentrate on that. They talk irrelevant sometimes. We are more interested in designs, it seems. It seems that our engineering community thinks of top level work and not of real work. I have seen engineers design, they talk a lot on designs and they think only academic qualification is more important than work on site. Work on in organizations, manufacturing units, and this doesn't work. You have to keep balance. I have seen many videos on sites. Many engineers produce videos on sites, and I don't like those videos because those videos are based on no quality control. If you see that rusted steel is being used and engineer gives videos of that, publishes videos of that, they don't talk of rust of steel. They talk only what they know. So a message goes to public that rusted steel can be used, and that is not the right way. I have seen everywhere in almost all buildings, all structures, whatever government body or private body, all are same. Steel reinforcement is stored in sometime on ground, in soil below, on soil directly put that. They don't even have courage, have some note to keep some raised platform, to provide a raised platform for steel storage. And that is very small point I'm telling you, and the steel lies in, it may be moisture on that, rain may fall on that, nobody bothers, and steel gets rusted. And sometimes I've seen steel transported in bent bars means 12 mm diameters, bent and brought, and then it is straightened and used. That's another nonsense, and people do it knowingly or unknowingly. Maybe they don't understand what they are doing, but they are doing. Contractors don't care, builders don't care, and engineers never point out. Unfortunate it is that so highly qualified engineers in my country, civil engineers, and they don't point out that. So that's what I say. Quality is very important part. It has to be. It doesn't cost anything extra, I'm sure. It's wrong to say if you study and maintain quality, it will cost more. Actually, it will cost less, because work quality is more, is higher. And coordination means you have to know everything about that project. You have to of course chart out a plan how to do it, and according to that plan you have to progress, you have to move that project. And when you have to move that project according to your own progress schedule, certainly you will keep in mind every time what material is required, when material is required, what stage you get this design, what stage you get this, what means every sequence you have to formulate based on your plan or based on your schedule. And when you have to decide that this resource, whatever is required, should be made available at right time. And if you don't make it available at right time, then that activity cannot be done, cannot be worked out. You cannot carry out that activity if resources are not available in right time. So I can say quality and coordination together are clubbed along with quantity. If you want to produce quantity, duly quality, with due quality and you can say respect, regard. Quality and coordination are a must to be effective, and not to say only we have done it. It should be seen that quality is achieved, and it should be seen that sequences are done. So I say we can do only when we remain serious, and designs people, those who are involved in designs, they have a responsibility of ensuring that site information is provided, whatever is required for construction ability or buildability, which term construction ability or constructability and buildability, or how to build that capacity, that procedure, that ability, that must be clearly defined. We cannot leave it to others just thinking they will understand themselves. Design people are understood to be very intelligent, very brilliant, and information they give should be clear, explicit, and not based on assumptions or industrial practice. You should remember that site person, there are many classes of people, even site engineers, they remain hard work related busy. They run here and there, they have to work in every weather condition, and physically they get immediately tired. Standing in sun for many hours, you can't think person can concentrate on design issues or on quality issues or on coordination issues. If you expect that, in that case you have wrong conception about site work. Site work require intelligence, site work requires physical action, site work requires inspection action, and site work requires workers control, machines control, program control. Means that person who works on site, you can't expect him to have same capacity in office as designers are, planners are, or you say those who work in offices. Office engineering is different than site engineering, because office engineering has to lead site engineering, has to lead that. You cannot, both may be equal, I don't say no. Site engineering has its importance, whereas office engineering has different kind of importance. In fact, site engineer can be a good support to site, office engineering can be a good support to site engineering, because office engineer provides detail to site engineers through whatever medium, through document control or what, that information. And you don't think that's when site guys get information, they immediately read that, or because I don't expect this. And maybe they don't have organized office. Certainly sometimes site people don't have organization, and organization by office people is well managed, and therefore there should be frequent meetings between both. Site person cannot be that level qualified. Sometimes diploma engineering qualified people work on site based on experience. Some also degree engineers, of course, degree engineers don't work to work on sites, but I think every engineer should work on site, even if you are a master's or a doctor. It's better if you work on site, because site teaches a lot. What problems do sites have? We have to get this. If you don't expose yourself to that, then how can you be engineering expert? You cannot be. Problems must be seen being physically. It doesn't matter if you go just forward. No, it doesn't matter. You have to stay for some time to see how activities are done, what problem site will feel. You have to help them, because if you help them, you help your own design, you help your own project, because you spend a lot of time and a lot of mind in designs, and that's not easy, I know. It's very time consuming. Of course, softwares are available. Even then, quality is quality, work is work. Your details should be as such that there should be your details should not cause any problem on execution, on working. And if those details are, you can say, quality, those are quality wise good, easy to read and easy to do, it helps site people a lot. Otherwise, if a lot of time is spent in reading details, I don't think that is good detail. And that's point we have to keep. Designer has to keep in mind. Yes, you can do whatever. Of course, you should know what problems this design can create on site, and that you can only when you know what are site problems. Imagination does not work everywhere. Imagination works only before doing design and not during design or after design. After design is done, it is only work that is to be physically created, physically delivered based on designs, and designs can be transformed to work practically on site only if design is clear and site guy understands that. And I am particularly using term site, and site here doesn't mean work site only. This means manufacturing unit also and processing unit also. Means whatever relates to some area. Here site means work area. What I say is very important point, and we have to think about that. That's what I say. We should not sleep. We should not sleep in designs as well. We should not sleep on site. Sleep is neglect of work is called sleep. We have to concentrate on work at every point, and we should not ignore anything. And ignorance, once you ignore, it's difficult then to find out where problem was, because ignorance itself means a problem. And I cannot work in my profession without quality and coordination, and of course with concentration. And that's what is very important point here. And that if quality leaves work, if quality leaves you, it's very difficult. Quality, that's why I ask quality. You cannot leave me because you are my destiny, and I consider quality my destiny. If quality is my destiny, then good work is my destiny, and if good work is my destiny, then good future is my destiny, good development is my destiny. And it applies to every nation, and our nation must train itself to get good quality, good production, and to prove to world that we are really a knowledge society, which we claim. And it is engineers only that can handle it successfully. Of course, you have to pay price for that. You have to strongly work. You have to work with dedication, and we have to work with concentration. You have to work like using your eyes as not wasting your vision, but to use your vision for work. And engineering profession is as such, it's not easy to work in profession if you can't do all this. Then you are not engineering professional in that case. And quality engineering and coordination engineering are very important terms. And if quality is achieved, I think you can be number one in world. You may claim you are number one, claiming is not enough. Still, you are not valued to that level as you should be. And that's why racial approach works, which we say, oh, they are racial people. They are not racial people, but we are not. We have to think racially in quality. My quality should be better than your quality, and you should claim that, and it should be. It may be working designs, it may be original designs, it may be manufacturing or construction or whatever. That's our own problem we have to solve. Nobody else shall solve my problems. My problems, it's my duty to solve, and if I cannot solve it, in that case I can say that I have lack of build ability or construction ability. I have to fix quality in my own. When I say I, this doesn't mean personally myself, it means every engineer. Every engineer speaks of my fixed quality in my country. Come what may, no excuse for concessions. I don't want any concessions on quality issue, because that is my requirement. I don't want any concession because it's my job, and job does not accept any concession. Work quality cannot be compromised, and this is a must. You have no right to compromise on work's requirements, work's quality, and we don't intend to compromise in name of system. System is different. System cannot stop me from quality controls, and we have to see that. Works must be done. System can fail, but controls must not fail. Controls as existed even before system came to being. Those controls have got no relation to system, because controls are controls and we have to stick to them. We define those controls, or courts define those, whatever you accept that this is my profile to work on this. Only this limit I will check. As you have to define that. depending on what type of work is that. We have to be very sure about that, and we have to make sure that quality must perform and must be delivered. But it doesn't happen currently in entire scenarios in our country, and we have to be very serious about that issue. And all whatever we think that we have some stoppages or some speed breakers, just like I say, can we bring working environment in? Working environment quality and coordination requirements. If yes, how to do it? That point we have to be very clear about. And certain red lines that must be turned green, that must be made, must. We have to think about all those issues. We have to think it certainly, we have to think seriously, and we have to do it every way. And that point we have to think on here. And we say every time I define this, but not necessarily every time we should define, we should understand this. Few points only are there. Can we know and apply quality standards complied with overseas, for example in Gulf countries, on buildings and on plants, facilities? That can be a question, because I worked in many Gulf countries and I compared quality of that country that time to what we had here. And that time there were not many machines in our country as Gulf had. That time there had been no many machines even to excavate, and we had no quality. In fact, I used to compare that, and that time there could be excuse, okay, we don't have so many resources. But now that excuse does not work, because we do have resources, but controls do not exist. Is still same situation. So why say can we work on coordination activities to achieve defined or expected quality profile on works? And that's what I try to add here, coordination activities. It's very important. Coordination is not understood by everybody correctly. It's very important area for engineering works, and if it doesn't work, you can say you cannot achieve your work, or you have to push it only just to finish it, and that's without coordination, without coordinated efforts. And why we should not revisit quality required specifications and update per world working standards requirement, and that's you have free hand for specifications. Nobody can control on that. Whatever you agreed for some project, that this level of specification is my requirement here, and that much if you fulfill, it's freedom, it's the highest degree of freedom, that you have to constrain somewhere, you have to confine somewhere, and that confinement is written document, and it's acceptable. Contractor would do that, or you do that. It's up to you. Why should we not apply coordination requirement? Is it not a must? Reliable solution? Is it not? That's the point. And really we have certainly worsening state of quality. Of course, I'm very concerned about that. I'm very concerned about worsening state of quality of works, and I think every engineer should be. When I say I, this means you. Really we have certainly worsening state of quality of work, and this I think should be realized by every engineer in our country, and how to improve such mandated works quality to certain minimum required marks, at least to match with minimum international requirements. When I say international requirement, it's coded requirement, it's international codes, and usually we when we produce our codes, we try to extract information from those codes which apply internationally. We just little edit and make some amendments or modifications to our national conditions. And should we not force ourselves to work on coordination in each activity? And that's the point here. Worsening state of quality of concrete, and how to improve such a mandated quality to certain minimum required marks. Concrete component in constructions amounts to major percentage of cost, and therefore cost and quantity also, and therefore it becomes incumbent on us to care about quality of such component. It's of course out of common and professional understanding that why do we have no seriousness in this regard. We are lacking seriousness, and that is, I think, root cause of this bad quality delivery. Worsening state of communication and coordination during working for engineering designs and executions or construction activities. Determined and dedicated role of engineers towards realizing these requirements, or else quality remains a myth. Do you want that quality should remain a myth? Nobody shall accept this fact because quality is to be achieved. Can we do it, or we are incompetent, inconsistent societies and of course communities in engineering? Are we incompetent, inconsistent? We have to decide ourselves where do we stand. Are we engineering force or incapable? Are we incapable? When shall we awaken ourselves? That's the point. Shall we transform existing engineering strength? Shall we transform existing engineering strength into standard quality working force? That's the point. Working force, standard quality working force means trained people in quality who shall decide about all such questions that are being faced in current scenario, and it is therefore very important point. Deliberations we have done many times, we'll do later on also. So what I say that whatever information must be brought to those personnel who require it, it must be provided in right time for right requirements and quite rightly duly coordinated and dissemination of engineering information about quality requirements and how to transform using method statements. We have to make it sure. And I move to a file that's coordination, engineering projects, public and engineers, and that's for reliable quality engineering. For reliable quality engineering, you can say coordination for reliable quality engineering works deliveries. Coordination engineering is a must, you can say, if you want really reliable works delivered. Coordination engineering is a must, and it's only a page I have written with so many details of my projects which I handled, and also generality. And we say missing coordination means missing good engineering, and do we want to miss that? It's an important point. And we say many questions I raised in this, and these questions are in few lines only, and we can say I repeat every time, but better we read it ourselves and we know. There are few lines only again, just for refreshing, and it is coordination engineering a must? On every project you have to find answer for this. What do you think? Project means all performance activities involved from pre-design stage to final completion of completed construction. Few difficult questions which are required to be answered by engineering community, and these relate to quality and coordination, respective involvements in entirety and not in part. Can we ignore these domains? Of course, I can say quality and coordinations are domains, and we have to decide, can we move without that, or we have to go with them? What do we engineers think over these issues? As mentioned, how many of us do conduct works for quality and coordination engineering? Is it not right time to contemplate and deliberate on this subject? Can good industrial practice be achieved on works or on products without moving through quantity, through quality and through coordination domains? Can engineering designs be reliably carried out without involving quality and coordination? But where are we going to? Without communication support and reliable coordination, we cannot do anything. And then there are certain projects, and I have gone through certain writings. Many times we have, this is a common file now for me to include in this talks because it's generality, and we have to add many issues such images to this, and you know, I'll show you what's the result of individual coordination. You can see this drawing, you'll find it's very complicated, very much detailed, cannot read it even if you zoom out, but zoom in I mean to say, but it is called coordination of various details together. It's not only talks or timings I am saying, it is technical details as well. Means even in same profession, same branch, you can do interaction of branches can also be resorted to that one. Whatever work we do means it should look as if it's a system. Actually, whatever we do systemized work. If we don't do systemized work, we cannot produce systems. It may be electrical engineering. If there is no balance, no circuit, nothing, no distribution, or no proper way of circuits, you can say phases, you can say, then you cannot produce. Electricity shall not work. Same applies to machine. If there is no coordination among its functionings, among its parts, among its sizes, machine cannot function. That's why I say coordination means everything related, everything involved should work perfectly, and it can work perfectly only when it is well coordinated. So we say there's so many projects here. I have not added all my projects, but few only from my memory and from records that I have, and ultimately we can say a lot of writing is done and shall be done also in future from various references, from internet or somewhere else, and from my own experience. It happens, and you can say this we from time to time we discuss, and I keep them upgraded if I get more information, because there is no formula which we can just fix on. And coordination is a free domain, and you can bring available information, put in that, or you can say done this. You cannot say it is finished. Coordination never finishes, and coordination has to be continuous. Examples, constructibility checks here, and we have to see this issued, approved for construction documents. Those documents which are meant for a work, these are generally called approved for construction. Approved by whoever, means engineer or whoever is responsible, even owner. Those documents must be authentic, you can say. Approved for construction pertaining to all disciplines, it's not one only. Whatever disciplines or details are included, these must be approved. I may call AFC, approved for construction, or IFC, it's also called IFC for construction. It is issued for construction, we call it IFC, and that's pertaining to all disciplines, must be checked sequence, and that's important point, say, and it's that one. And discipline wise, to make sure that these contain well coordinated information which being necessary for 100% construction installation of relevant portion or element. Project engineer or engineer, whatever you can call, should immediately notify all missing information to be provided proficiently, and that is very important. All clashes which have been worked out should be recorded, or have been discovered should be recorded in either documentation which are named as engineering technical query or site technical query. This use means how do you use it, it's up to you. You can name another title also, I don't mind, but here is questioning on that, clashes or missing information, or what should now, or some proposal onto that which you want to make, whichever required to be raised for a possible resolution without causing any delay to execution. Approval about queries procedure should be pursued personally in some urgent cases, and resolutions accommodated resolutions communicated to supervisor concerned for on-site implementation prior to making mistakes, and work should be carried out correctly. And we have to understand inference of technical documents or engineering documents. You can say engineering working documents or technical documents, or specific activities that I have to do, where specific actions are to be taken. Inference of technical documents is not easier. It's not easier an activity. Only a competent project engineer or a project leader or an experienced discipline engineer or domain engineer should be entrusted responsible job to explore missing information as well as to know about whether or not contractually issued documents provide adequate details for purpose of full construction, or yet technical queries are necessary to be raised depending upon sort of engineering coordination conducted. This activity requires, that is technical documents, this activity requires total concentration to study contents of designs, respective technical coordination and mutual interferences in relation to all involved engineering disciplines, not one, all, whatever are there involved on project, depends on volume of documents regarding what duration is required for complete understanding of technicalities involved on designs. Study and review should not be confined to design drawings only, but detailed specifications should also be studied so that complete project requirement is properly integrated for physical execution. The scope of project contract must be understood fully based on thorough study of components involved. Reason being given that in many instances, construction of contract specifications and drawings probably hide many works, but these acts and mandated certainly integrated parts of project, and we have to meet certainly for project, and we say engineering meetings for engineering disciplines form an extremely significant portion of contract. Work contract, project contract, construction contract, or construction and design and construction, or EPC, whatever you can say. Actually, this activity commences at tender negotiation time itself, when technical proposal is submitted. Clarification questions maybe in hundreds. We have to get issue clarifications from engineer's office or owner's office. Clarification questions may be in hundreds, for major projects, are raised by client on contents of included technicalities offered by contractors, as well as those considered at pre-bid stage as replied by client based on contractor submitted queries. For collection of important queries, meetings are conducted to resolve. We can say meetings are conducted to resolve concernable issues in hands, directly to be resolved by and between both possible parties. During contract stage, when design is submitted, meetings are conducted for every discipline for getting a satisfactory response on design questions, clarifications, and software related issues, or formal presentations of PDS project document system, that is PDS project document system. During this stage, the meetings generally conducted shall be very lengthy in time duration, but impart required efficiency for successful decision making process, and certainly save time for concluding approvals. Now, during construction stages, regularly programmed meetings are conducted for considering engineering difficulties or other issues related therewith, and to reach practical resolutions which would require urgent attention for continuing progress of works, obstruction free works. Whatever obstruction we meet have to be removed for proper flow of traffic. Such meetings more or less form part of regular progress review meetings until for until lot queries have been accumulated necessitating separate meeting exclusively either for specific groups of specific problems or for certain whatever related major issues. Day-to-day meeting, day-to-day meetings could often be conducted on site. Let me see battery percentages that way, please. It is 62%. Okay, we can still cover for 10-15 minutes. Day-to-day meetings could often be conducted on site between area engineers of two parties to resolve matters subject to approval of field engineering manager. We can say day-to-day meetings could often be you can say day-to-day meetings could often be conducted on site between area engineers of two parties to resolve matters subject to approval of field engineering manager or organizer or leader of client or engineer. Engineering meetings cannot be confined to aforesaid instances, but according to job requirements, these have to be conducted at whatever level of supervision to expedite site works progress movement to be in line to schedule. Such meetings also involve contribution from quality requirement assurance control engineering section on site for urgent decisions making and acceptable to construction department. Then construction method statements, that is another part of domain which is very powerful and very important, and it's not known to everybody what it should be done, how it should be done, and it's very important part during construction phase. During construction phases, activity-wise, construction method statements are required to be written, charted out, approved per project procedures, and issued to supervisors on site so as to adhere to activities related respective contents included on statements for smooth carrying out of activity concerned. These statements should be approved by client by engineer prior to commencement of relevant activity as indicated in foregoing. Method statement should be prepared by either project or discipline engineer or quality engineer or domain engineer or office engineer depending on availability on site and per job description. This document to be produced should contain full information about relevant activity to undergo considerations given complete know-how of work sequence and involved technicalities which shall be carried out followed by sequence of inspections that should be conducted based on requirement of inspection and test plan. Quality check lists as well as conducting necessary testing and materials. Testing laboratory involvement from time to time. All disciplines activities require production and approval of method statements. Method statements should therefore be prepared in advance and be checked as well as approved by site leaders. Leaders for further transmission to client engineer for final approval as issued for construction IFC or approved for construction AFC and circulated to site engineers as an approved professional working document. We usually call it professional document. No limit governs method statements. Numbers, how many numbers do you have or you need, which depends on work requirement specifically. Agreement has to be made between client and contractors on practical requirements of required site titles of method statements, which may cover general activities as well as particular activities. For reference to reader, for reference to those who want to read this, a number of method statements have been appended in other files, in other methods, only for guidance and knowledge exchange elsewhere. These statements are based on site practical experience and were used on projects. So it's very important these methods are from learning point of view because these were already done, used. Use them for guidance purpose only and not for do your job because, and create your own statements based on that guideline for specific application on your project. But basics of methods or procedure. Writing skills can be advised herein as indicated in following further explanations. And what to do in that case, how to write is very, very important point. Everybody cannot think, miss, you ask someone to write a method statement. A person has to think, what's being asked for, and then after that only one may raise questions, but here I'm saying definitely else. And what's that? And that is that just think of what solution is required. Means you think yourself, start yourself. What is problem and what solution can come out and what solution required, everything. So just think of what solution is required for a particular construction operation, what you have to do. And that's called contemplation, you can say. Contemplate means think imaginarily. You have to contemplate in your mind this template here, form a form work, you can say. You have to see or form it off in your mind. What do you want to write and contemplate on details about what works involve minor activities or on related issue and would certainly be encountered there on site. You have to imagine in contemplation that you are on site, you are working for that activity. What do you need for that activity? You have to think yourself and then you have to come back to writing method statement and chart out all those. Contemplate on details about what works involve minor activities are on related issue or would certainly be encountered there on site. What sequences and materials to be used for temporary as well as for permanent inclusion. Means sequences of and materials you have to use there. Metals include machines also. What are other requirements for accomplishment of operation from its inception of activity to its final outcome. This is what we have to do. Now, after having considered all these requirements, sequence out thinking hypothetically that you are available on works and carrying out that activity. Activity should be sequenced one after another, other and respectively, and write statement lines and then recompile to a comprehensive statement, and if also required for reference. Certain sketches or plans could also be included for clear direction. Certainly would be scheduled there a long list of method statements or procedures pertinent different engineering disciplines. For example, certain activities titles are indicated which may not be end of issue but just for guidance purpose. And you can say here soil exploration in entirety. Soil exploration in entirety and design is also a part of scope of contract. site preparation for upbringing existing natural ground to certain defined levels, along with, if so required, soil improvement in general, life camp construction for all personnel, and life camp means where people stay during that period, temporary facilities establishment, earthworks in general as well as specific, then excavation in foundations, compaction of formation level, blinding concrete, and concrete protection or waterproofing formwork, reinforcement fabrication, reinforcement assembly or placement formwork, concreting or placing concrete in various elements, block or brickwork in walls, finished finishes activities such as plastering, rendering, etc., complete HVAC system including duct fabrication and duct fixing, including all accessories, chiller units, air handling units, package units, etc. Electrical system including both fixes 1 and 2, and of course loss prevention system such as smoke detectors, FM 200 or energen gas used for specialist gas fire suppression system. It's not loss preventive but gas this is fire suppression system, firefighting system. Aluminium works for doors, windows and curtain wallings, cladding works for steel building sheds, structural steel erection at low as well as, let me see, battery issue coming of 49%. Okay, let me wait. I can say cladding works for steel building sheds, structural steel erection at low as well as high at high level roadworks, paving for internal stressed streets and walkways, utilities piping both below and above ground, pre-commissioning, testing, commissioning, performance testing, maintenance, quality testing, and many more depending on scope of projects and its components. It's not practically possible to produce all methods in one go, but it takes time and its action should be quite in advance of commencement of relevant activities, prosecution, duly allowing time for procedure based approval when such statements should be prepared and submitted for approval. Basics of activity should be conferred in details with relevant involved supervisors, relevant involved quality personnel, and then finalized to specifications and design requirements. Documents should form an integrated approach towards each activity, for such detailed job has to result in formation of certain professional documents. Remember that no considerable works can be allowed without approvals of professional method statement or procedure statement, which means if delay is caused due to whatever reason, for sure implementation or carrying out activities shall be long delayed, impacting on completion of component. And engineering detailing is very important part on such designs. If these are not done well, means there's always existence of problem. After having received, preliminary drawings approved by client, design team should concentrate to produce all necessary drawings, which would then be submitted along with building permit application to relevant municipality if so required, otherwise no problem. Design engineer should also commence with detailing of all structural and architectural statements of proposed included parts of project. All other disciplinary details should also be taken up simultaneously. This part always consumes much time, and therefore adequate staffing should be allowed for details production. Such detailing activity should include sections, various elaborations or depictions on plans, details of all elements necessary for execution, prosecution, or for transmission of information to equipment shop floor drawing engineers. For working drawings, production details, deliveries, it shall require it shall require definitely production hundreds of such details discipline wise. Cross checking must be applied to all these details prior to giving a final approval. Working out details shall require multiple considerations of thoughts to be given for end results of design so as to make it necessary or convenient for ease of construction execution with application of minimum efforts with keeping cost to a minimum as far as practically feasible. Concept of detailing is a cumbersome job. It's not so easy. Concept of detailing is a cumbersome job, you may say, requiring competent skills on part of design engineers who coordinate mentally all possible operations related to designing and following up construction by proposed details. Details dictate about many outcomes on site and help construction engineers a lot. Construction engineers a lot, and you can say, if well thought of, required successful constructability in advance. Sometimes good looking details are badly, adversely, you can say, difficult for work execution. May say sometimes good looking details are badly, adversely, or adversely difficult for work execution. Details should be worked out as easy as possible to save procurement as well as execution time duration to minimize cost. It's therefore suggestible that as far as practicable, standard items should be included in designs for easy procurement. Also, these items are well known to experienced supervisors involved with construction activities operations. A typical details delivery shall give good results for production purpose, while unnecessary details should be avoided. Details should be drawn up explicitly in an easiest way based on effective engineering coordination, which should result in making details as easy for certainly easiest interpretation of design references. It has been experienced that the multiplicity of various involved documentations or documents related absence of coordination creates unnecessary difficulties for execution team for carrying out works while clashes discovered and others such failures pertinent considerations of necessary details as well as so many other factors result in raising engineering or site technical queries which we write as ETQs or STQ respectively. Such queries further augment red lines, recordings and execution complexity, which generally happens due to involvement of many hands as well as change of heads on same job. Some competent engineer should concentrate on one activity to draw it to a conclusion conclusive decision delivery so as to be finally sent it to drafting section. Also, cross-reference on drawings should be properly reflected because there may be many chances of missing certain details. It's also suggested that what details are required should be planned in advance of commencing detailing work in form of a drawing and detailing working schedule to keep a control on quantities of detailing work. It's recommended if possible. Let me check again because it's very important. It's now 38%. It's better in interest. I'll forget otherwise. Let me put up. I worry about this. Put up. Maybe I forget. Okay, I put up because sometimes the internet goes off here. So I say also cross-reference on drawing should be properly reflected because there may be many chances of missing certain details. It's also suggested that what details are required should be planned in advance of commencing detailing work in form of a drawing or detailing working schedule to keep a control on quantity of detailing work. It's recommended if possible, designers should have equipped with reliable information from experienced site professionals while finalizing thorough details so that design reviews and further work may be made easy for all engineering personnel who would be required to physically prosecute all such works. A long list of site technical queries and ETQs indicates that designers had not been effective to produce details to required standards and certainly worked haphazardly without following up necessary concrete action plans. Comprehensive designs are required for easy every easy follow-up, procurement and related per usual actions on site and not just haste-based drawings, and that's what they say. It's not charging. Why? It's charging. Okay. Therefore, it shall be good in, I say, in I say, which results in undue wastage of whole team, allotted time, and consequently impact on control. I say, comprehensive designs are required for every easy follow-up. Comprehensive designs are required for every easy follow-up, procurement, and related personal actions on site, and not just haste-based drawings that state and require many revisions, which results in undue undue we can say results in undue wastage of whole team allotted time and consequently impact on contract duration. Therefore, it shall be good in interest of all design and project professionals to work in cohesive team so that intensive successful coordination remains continued to reach project closure to define completion daily or sooner date or sooner define completion date or sooner if it can save contract time. And here are examples pertinent engineering coordination affected on certain projects which we'll take later on. Now we move to file, and that is a competent file specification file. We are talking of issued by Japan Society of Engineers, and this is now we are on page construction plan. Before this we were up to definitions, verification of construction plan. I just read it for you because I will discuss this also, but for refreshing purpose it's necessary to be referred to, and it is that an appropriate construction plan shall be prepared to construct a concrete structure indicated in design drawings and specifications. Construction plan shall meet requirements for construction work concerned and shall be approved by owner after it's confirmed that concrete structure indicated in design drawings and specifications can be constructed. And there's a commentary letter what it says, preparation of an appropriate construction plan and carrying out construction work in accordance with construction plan are essential for construction of a concrete structure that has performance attributes. And these are safety, serviceability, restorability, durability. Restorability is important here. And as specified at design stage. And a figure showing here, you can say figure shown that says, let's say this is construction plan, has performance requirements for structure and requirements for construction work. Means whatever we construct, we should perform, and that's a requirement to define. So it goes to design of structures, and you can say construction planning. Both are detailed and linked in. Before also we discussed what to do. In this case, determination of structural detailing, what you have to do, determination of concrete details, determination of reinforcement details, and determination of construction method. So construction method which we determine here in design of structures. And all these 3 points, determination of concrete details plus reinforcement details plus construction method equal to, it goes to determination of characteristic values of concrete. That's the important point. Characteristics values of concrete. And then you say determination of maintenance details. This was structural detail, then you have to determine maintenance, and that is verification performance of structures, and that is verification related to earthwork action, earthquake action, safety and serviceability, environmental action, initial cracking, that we have to think in concrete itself. How shall it behave during earthquake and during safety and serviceability, and how environment shall impact on it, and what about cracking. And then we can say documents, we can read what is specifications, inspection planning. You can say construction planning, we can call it, and it says determination of construction methods. Determination of construction methods means what methods are there, how to transport, how to reinforce work, reinforcement to how to do, and how to do form work, about placing, about compaction, about curing, joining work, finishing. So construction planning issues. And if you say these determinations of construction method goes to, you can say determination of construction performance and determination of manufacturing method. So both are the construction performance, and which further relate to concrete mix design, and of course then come down how to do. And so environment and safety planning we have to do for purpose of work on site. We do form work, placing, compaction, all that. And quality control planning, inspection planning, all these are involved. And when you go to concrete mix design, selecting materials, selecting mix proportions, and verification of concrete performance. It is okay with determination of mix proportions and confirmation of construction plan and start of construction work. We can say considerations in construction planning. What we have to construct, what you consider is, what you have to do is important point, and that point we have to bring here. Construction plan shall be prepared taking into consideration environmental conditions. It's very important point. And construction conditions at construction site, giving consideration to construction safety and environmental loading, construction safety and environmental loading, and developing plans for details such as overall schedule, construction methods, concrete manufacturing methods, construction performance of concrete, concrete mix proportions, quality control, inspection, environmental impact and safety. I repeat, considerations in construction planning which shall be prepared taking into considerations environmental conditions and construction, environmental conditions and construction conditions both at construction site, giving considerations to construction safety and environmental loading, construction safety and environmental loading, and developing plans for details such as overall schedule, construction methods, concrete manufacturing methods, construction performance of concrete, concrete mix proportions, concrete quality control, inspection, environment impact and safety, And if you think on this, what we can do further on this is, let us say, a construction plan must be developed in due consideration of quality achievement. So your plan should be that competent that it can digest quality requirements. A construction plan must be developed in due consideration of quality achievement, construction period, safety, economy and environmental impact so that construction can be carried out successfully. Safety measures against risks. Safety measures against risks expected at construction stage must be carefully studied in advance. Environmental conservation plans must comply with all environmental laws and regulations and standards related to construction work. It's also good practice when preparing a construction plan to take into considerations items for which there is as yet no standard to meet so that environmental loading can be minimized. Table shows certain items we have to consider when drawing up a construction plan, and these are for guidance purpose. What are these? We have to take into our account, that is, plan for transportation and receiving concrete, haul road plan, placement plan, compaction plan, finishing plan, curing plan, jointing plan, reinforcement work plan, form work and you can say false work plan, environmental conservation plan, safety and health plan, others. So in others, anything, whatever you want to add, you can add. Only when we read later on this, and plan for transportation and receiving concrete, because concrete is a very, very important item. It's to be manufactured, and that's why it's important. It's time limited, of course. But after manufacture, you can't wait. Plan for assignment, plan for transporting and receiving concrete, says plan for assigning and operating agitator trucks. Haul roads on-site tests, you can say haul roads on-site tests. Inspection areas, inspections of concrete mix proportions, and slump air content, water to cement ratio, etc. These are all descriptions for transportation and receiving concrete, and there may be many more factors which are not given here, but you will find elsewhere. There may be temperature issues, there may be how your water rotation, your mixture should move with the work. Likewise, timings from start of loading to disposal. Haul road, how should be haul road, hauling method, concrete supply capacity, standby pumps, trucks, and placement means construction organization or chart, you can say placing intervals, hourly placing rate, safety, etc. And our compaction plan means type and number of vibrators corresponding to hourly placing rate of concrete. Personnel requirements, preparation of standby vibrators, replacement personnel, and you can say skill level of finishing workers. Skill levels of finishing workers, plan for time of finishing, finish accuracy plan, confirmation of equipment to be used for finishing work, curing plan, time of initiation of curing method, confirmation of curing period, confirmation of curing equipment, confirmation of persons responsible for concrete curing controls. And jointing plan means jointing method, treatment method, equipment, time of jointing, and reinforcement work plan, confirmation of reinforcement, bar diameter, spacing method for ensuring concrete cover, assembling method, type of reinforcing steel, fabrication method, skill level of reinforcement workers. Formwork and false work plan means design of formwork, lateral pressure consideration, confirmation of formwork material, and false work, materials, form work, designer, timings of form removal, timings of false work removal, lateral pressure control method, environmental construction conservation plan, washing water, curing water, drainage of bleeding water, checks on noise and vibration, dust, and environmental impact, etc. At and around job site. Safety and health plan confirmation of matters related to safety and health and construction workers. Others confirmation of troubleshooting methods if you have, and many more such plans can be checked in. And that's an important point. Then we can say determination of concrete method. How to determination of concrete method? It's also important point here. Determination of concrete method. That's what you say about this. It's really something important here as well. We have to says appropriate methods of concreting, including hauling. We started with the iron plan, placing, compacting, finishing, curing, etc. These are appropriate methods of concreting. A construction site shall be selected in due consideration of influence on quality of concrete in structures. In cases where a new construction method that is thought to be more suitable for construction work concerned than a standard construction method assumed as design stage is used, influence of new method on quality of concrete in structures shall be ascertained through experiments or by other means. That's important, and we can say all that, and we can say all that in an easy way means appropriate methods of concreting we have to think of, and in cases where a new construction method that is thought to be more suitable for construction work concerned than a standard construction method. We have to be careful about that. And we have to think of that logically. In case a new construction method that is thought to be more suitable for construction work concerned than a standard construction method assumed as a design stage is used. Influence of new method on quality of concrete in structures shall be ascertained through experiments by or by means. In order to achieve required quality of concrete, it is important to employ an appropriate construction method and carry it out in a reliable way. At design stage, structural details and various materials properties are determined, assuring use of a widely used standard construction method. As construction details such as construction requirements, weather conditions, environmental conditions, and concerning related conditions become concrete and specific. However, it may be more appropriate to alter construction method. It's good practice, therefore, to take a flexible approach and select most appropriate method in view of conditions of construction projects. Decisions on construction methods in such cases may be made with reference to construction methods described in construction standard section. If a newly developed, poorly field tested method is to be used, it is necessary to conduct construction tests under realistic conditions in advance to fully ascertain quality of concrete in structure that can be achieved by that method. Determination of construction performance of concrete. Construction performance of concreting. Appropriate construction performance of concrete shall be specified according to construction method to be used. Appropriate construction performance. Appropriate construction performance of concrete shall be specified according to construction method to be used. If construction performance of concrete cannot be specified, previously determined details such as construction method shall be reconsidered. If why? Because if construction performance of concrete cannot be specified, well, this is just a commentary on this is construction performance of concrete includes work ability such as filling, ability of you can say pump ability, you may say pump ability, setting properties and strength development properties. It's important to specify construction performance of concrete required at different stages of construction in due consideration of changes over time in properties of fresh concrete. Concrete with appropriate workability is easy to handle, pour and compact appropriately according to conditions such as placing site locations, cross-sectional shapes and dimensions of members, and reinforcing steel arrangement. Workability, however, is a property that can change over time at different stages of construction, from manufacturing, transportation, pouring and compaction. Changes over time in slump vary considerably depending on concrete mix, proportions, type of materials used, and environmental and weather conditions during construction. Workability must be specified, therefore, after careful consideration such time dependent changes. In cases where concrete is pumped at construction site, it is desirable that concrete can be pumped at required rate under planned pumping condition without encountering clogging of pipes, and quality of fresh concrete be not severely affected by pumping. Concrete with excellent pumpability. Concrete with excellent pumpability is concrete that has a well balanced combination. Concrete with excellent pumpability is one that has a well balanced combination of these properties, namely ability to flow smoothly in straight pipes, that is fluidity, property of fluidity. We should have good fluidity, ability to pass through bent pipes, means pipes are there, bends are there in that system, ability to pass through bent pipes and tapered pipes. There is deformability and resistance to segregation due to changing pressure in pipes. Segregation resistance. So we should have it may known as fluidability and deformability, segregation resistance. Setting properties are related to conditions such as compaction of concrete, that is setting properties, compaction of concrete. This previously was properties, means that's where physically you can say pumpability, you could call it pumpability properties. Now we call compaction of concrete. Lateral pressure and solid, so settling properties are related to conditions such as compaction of concrete, lateral pressure acting on formwork, placement interval, you can say and it's very important placement. Intervals and raising and timings of finishing. Important timing of finishing in case of hot weather conditions, concrete or cold weather concrete. It may be necessary to add setting properties approximately or appropriately to accelerate, retard setting. Appropriate strength development properties are needed. Appropriate strength development properties are needed to ensure safety of structure being constructed against loading expected during construction of structure, and achieve rational construction and required performance of completed structure. Concrete strength during construction. Concrete strength during construction is under influence of factors such as placing temperature. A simple point is placing temperature, material of formwork, what sort of formwork it is, material of formwork, curing method, and ambient temperature. It's therefore necessary to take these points into consideration when deciding on timings of formwork and false work removal. Strength development properties may be necessary in order to remove formwork and false work or achieve early initiation of pre-stressing tensioning for pre-stress concrete. If required construction performance of concrete cannot be achieved, construction method must be reconsidered. For example, if required workability or pumpability cannot be achieved by carrying out a long distance pumping plan, it is necessary to revert to concreting method determination stage and make necessary changes such as changing concrete hauling method within construction site. Materials and what's the only materials of proven quality shall be used as concrete materials, and that's the important point. Only materials of proven quality says using appropriate materials. My dogs are barking. Why these barking streets? Such a disturbing. I can't hold it. Using appropriate materials is very important for producing concrete with required performance. Whether particular materials are suitable for use can be judged from test results or past performance data. In general, materials conforming to these specification standards or other quality standards may be deemed to be materials of proven quality. It is possible, however, to meet performance requirements for concrete even if materials not conforming to quality standards are used. If such materials are used, you can say it must be ascertained in advance that performance requirements for concrete structure can be met. Concrete materials of whatever quality may be used as long as concrete made by using those materials meets performance requirements. In case of poorly field test materials, tested materials, however, it's necessary to carefully evaluate their quality and performance of concrete, including long-term stability of quality and influence on durability of structure made of those materials. Concrete mix design. Concrete mix design is in proportions that shall be determined taking into consideration of such factors as constraints related concrete plans, availability of materials and economy, including transportation cost, so that required performance of concrete can be achieved. And commentary is mixed design refers to series of tasks. Mixed designs refers to series of tasks performed to specify materials. Mixed design refers to series of tasks performed to specify materials and their mixed proportions so that performance requirements for concrete can be met, usually in mixed design process. Materials and their mixed proportions are assumed and trial mixing is carried out, and this cycle is repeated until it is confirmed that concrete mixes made in this way meet all performance requirements. Characteristics value, because there are many combinations of materials and their mixed proportions that meet performance requirements. What is to be done in mixed design stage is to select appropriate ones from those combinations. Performance attributes required of concrete here include characteristic values for concrete induced by design, and construction performance of concrete material, conditions and mix requirements shown for reference only. Verification of concrete performance. Verification of concrete performance that we have to think of is very important also. Verification of concrete performance. It shall be verified that concrete made with selected materials and mixed proportions meets characteristics value criteria indicated by designs. If designs indicates reference only, values related to construction. If designs indicates references only, values related to construction besides characteristics values shall be verified that selected materials and mixed proportions meet reference only values or meet concrete performance requirements on which reference only values are based. Verification of concrete performance. It shall be verified that concrete made with selected materials and mixed proportions meet characteristics value criteria indicated by design. If design indicates reference only value related to construction besides characteristics value, it shall be verified that selected materials and mixed proportions meet reference only values or meet concrete performance requirement on which reference only values are based. It shall be verified that concrete made with selected materials and mixed proportions meets characteristics values criteria indicated by design. If design indicates reference only values related to construction besides characteristics values, it shall be verified that selected materials and mixed proportions meet reference values only values or reference value only values to meet corporate performance requirement, concrete performance requirements on which reference only values are based. Now commentary on this. We have gone through this already, just repeat. Commonly used methods of concrete performance we have discussed. Again, it is commonly used methods of concrete performance verification. As of this writing includes experiment based methods and method of making inference from past performance data. Characteristics value for concrete to be verified includes strength, carbonation, coefficient, diffusion, coefficient of chloride ions, freeze-thaw resistance, chemical attack resistance, alkali-silica reactions resistance, water permeability coefficient, fuel resistance, and drying shrinkage strain. Values indicated for reference only, such as metal conditions and mixing requirements and workability, pumpability, set properties, strength development properties specified in construction plan also will be verified, and this equation we already discussed. So we move further. Confirmation of alteration of construction plan, and that's also very important. We just read its title and see what we did. Confirmation and alteration of construction plan. It must be confirmed by an appropriate method that concrete construction plan meets the requirements of construction work and performance requirements for structures are met. Changes in construction should be made so as to minimize influence. As a general rule, changes in construction plan should be limited to concrete mix, proportions, and construction methods. If construction plan differs from reference values indicated in design stage, cracking checks at construction stage shall be made again under conditions reflecting construction plans. So we'll move to next one. No need of chapters. Now construction common 2. So these are some comments here. I'll go fast if you wish. Construction plan must meet requirements for construction work. Construction plan must meet requirements for construction works and must be sure that concrete structure built in accordance with plan meets the performance requirements. That's important. Contractor submits a construction plan in writing to owner, and owner checks whether structures shown in design drawings in specifications can really be constructed and approved construction plan. And to be more specific, it is necessary to check each task in accordance with items to determine whether or not standard construction methods specified in construction standards of these specifications are used, whether plan has to adequate margin of safety against variable factors expected in connection with each task, whether plan incorporates troubleshooting methods, etc. If new technologies or new construction methods are to be used, then it's necessary to evaluate forcibly and rehabilitatingly by reference to reliable documents or conducting full-scale field. If construction plan is to be channeled to change, result in change in other conditions should be minimized. You can say realistic way is to say stay within framework of reconsidering construction plan instead of reverting to design of concrete structure. Usually, making changes in construction mix proportions or construction methods specified in construction plan suffices. At design stage, concrete and its placement methods are assumed and not. Checks are made on initial cracking and characteristics values for concrete are determined. If these conditions in construction plan differ from conditions assumed at design stage, verification on cracking shall be again done on a needed basis. Now we come to plan construction. Chapter 3. It's very important one. We have to be seriously careful. Construction of concrete structure shall be carried out in accordance with construction plan if you have drawn, you have charted out. Construction of concrete structure will be carried out under supervision of domain engineer with sufficient knowledge and experience in construction of concrete structures stationed at construction site. If construction plan cannot be followed at construction stage, appropriate measures shall be taken so that performance requirements determined at design stage cannot be met. Simple. And commentary is basic rule for construction is to carry out construction work economically and efficiently by using an appropriate construction method on condition that construction safety is maintained. Construction safety is maintained because concrete work involves a variety of tasks such as tasks related to formwork, reinforcing steel and placing of concrete. It's desirable that concreting work be thoroughly coordinated with other types of works so that construction work can be carried out efficiently. To construct a concrete structure, contractor prepares a construction plan that details necessary construction processes based on design, drawing and specifications. Construction or construction of concrete structure therefore must be carried out in accordance with construction plan. In general, quality of construction is heavily dependent on human factors such as experience and qualities of constructors. It's very important therefore to station domain engineers. Therefore to station domain engineers with sufficient knowledge and experience in field of construction of concrete structures at construction site so that construction work carried out under direction of those domain engineers. In a construction project, incidents not expected at planning stage may occur at construction stage. It's not always possible, therefore, to carry out construction in accordance with construction plan. It's difficult to follow construction plan in real constructing project. Constructed concrete structure, construction prepares a construction plan that details necessary construction processes based on design drawings and specifications. The construction plan of concrete structure therefore must be carried out in accordance with construction plan. In general, quality of construction is heavily dependent on human factors such as experience and qualities of construction. It's very important therefore to station domain engineer with Sufficient knowledge and experience in field of engineering. Construction of many, you can say, it's very important therefore to station domain domain engineers with sufficient knowledge and experience in field of construction of concrete structures, stiffness of construction site SRR, so that construction work carried out under direction of those domain engineers. In construction project incidents not expected of planning stage may occur at construction stage. It's not always possible to carry out construction in accordance with construction plan, and if it's difficult to follow construction plan, you can say it's difficult to follow construction plan. In real construction project, appropriate measures must be taken following domestic domain engineers instructions so that required performance can be achieved. Quality control. Contractors shall perform quality control at each stage of construction in order to create a concrete structure that meets performance requirements. Quality control shall be performed as a voluntary activity of contractor by using a method that can be expected to be effective. If quality control has revealed a possible quality problem, appropriate measures shall be taken in accordance with domain engineer's instructions so that control shall be performed, quality control shall be performed as a voluntary activity, and voluntary means you have, of course, it's mandate, but you have to do it yourself by using a method that can be expected of effective in quality control has revealed the possible quality problems. Appropriate measures should be taken in accordance with domain engineer's instructions so that performance requirements specified in design can be met, and it's very instrumental in commentary, and you can say in order to create a concrete structure, in order to create a concrete structure that meets performance requirements, contractor must always carry out construction in accordance with construction plan and perform quality control by appropriate methods for appropriate items such as concrete materials, reinforcing materials, equipment and construction methods to ensure that required quality is achieved at each stage of construction. It is advisable, however, to perform quality control only for necessary items, only as often is necessary, instead of conducting many types of tests and collecting as large amount of data. One way to check on quality on basis of test results, besides actually conducting tests, is to examine manufacturers' test reports, as in case of specifications conforming products. Usually wide variations are in quality of concrete placed to build a structure not only increases possibility of occurrence of problems at construction stage, but also necessitates use of large factors of safety at mixed design stage so as to achieve a required strength. This makes the construction process uneconomical and in many cases causes decreases in durability, cracking, resistance and appearance. Always producing concrete of suitable quality, therefore, is essential, and it's important to control quality of materials and concrete manufacturing process carefully. Usually, I repeat this paragraph usually wide variations in quality of concrete placed to build a structure. Structure not only increases possibility of occurrence of problems at construction stage, but also increases or necessitates the use of large factor of safety at mixed design stage, so as to achieve required strength that makes the construction process uneconomical, and in many cases causes decreases in durability, cracking resistance and appearance. Always producing concrete of stable quality therefore is essential, and it's important to control quality of materials and concrete manufacturing process carefully. Contractor must prepare a reliable, efficient and economical quality control plan in accordance with construction plan, and carry out construction work in accordance with quality control plan. Quality control results may be used as substitutes for result of inspection conducted by owner at each stage of construction. It's desirable, therefore, that quality control be performed whenever possible by a technically or otherwise proven method. If quality control has revealed a sign of a considerable variation in quality, it is necessary to conduct an investigation to identify cause of such variation and take corrective measures so that variations can be kept with predetermined range. It's in event of abnormality on a possible quality problem, appropriate measures must be taken in a timely manner in accordance with domain's engineers instructions. Inspections. You have to give me a few minutes. I'll be back with my few minutes please. I'll be back, okay? Meanwhile, you can read this inspection, and that's no issue. So I think you've gone through this, and that is chapter inspection. It's an important one for inspection, and we can say that it is something different, and it is that owner shall conduct inspection at each stage of construction. Actually, owner's behalf it is owner shall conduct inspection at each stage of construction, and upon completion of a structure on owner's own responsibility. Owner of a structure shall draw up an inspection plan through engineer in accordance with design, drawings and specifications, taking into consideration degree of importance, intended use and purpose of structure. Inspection shall be conducted in accordance with inspection plan by a method of proven reliability. If inspection is failed, correction or corrective measures to be taken shall be considered. What methods to be taken shall be considered. If corrective measures cannot be taken, stage of construction that failed to pass inspection shall be redone. That's a very important point. Inspection plan, inspection results shall be maintained during service period of structure. In order to construct a concrete structure indicated in design drawings and specifications, inspection is conducted at each stage of construction to check whether construction work being carried out is adequate. Required performance of concrete structure can be ensured by checking on performance requirements such as safety at design stage and conducting inspection at construction stage. Inspection therefore must be conducted on responsibility of owner of structure. Performance of a newly completed concrete structure performance of a newly completed concrete structure. Performance of a newly completed concrete structure should ideally be inspected directly. Items related to a concrete structure that can be inspected, however, are limited to only a fraction: concrete surface condition, locations, shapes, dimensions of structural members of all inspection items. A realistic approach, therefore, is to conduct necessary inspection at each stage of construction to make sure through a series of inspections that concrete structure is being constructed as indicated in design drawings and specifications. Owner of structure needs to draw up a reliable, efficient and economical inspection plan with reference to design drawings and specifications in view of degree of importance, intended use and purpose of structure. In general, inspection is planned taking into consideration such factors as type and scale of construction work, staffing, timing of construction period, reliability of materials and construction methods used, skill level of construction workers, degree of influence on work schedule at subsequent stages, and efficiency. Inspection plan must describe things to be done. Must try to describe things to be done. And what's that? Must describe things to be done, inspection criteria, etc. It's not practical that honor inspects all items, because inspection items are diverse at each construction stages. In this way, contractor inspects quality inspection items for materials except for inspections related to construction works and structure on their own responsibility, and honor ensures inspection results. To make this practice work, honor should discuss inspections methods with contractor before actual construction begins. Results of discussion should be recorded with written documents, where honor records on an inspection planning document while contractor records on a construction planning document. Because honor of structure has to judge because honor of structure has to judge acceptability of concrete structure through inspection, reliability of inspection. Reliability of inspection method needs to be ensured by supportive technical information or other evidence. Acceptability criteria are one of important items agreed upon in contract. So they must be objective. Common practice is to use methods specified in Japanese industrial standards or JSC standards. Construction inspection standards of this specification indicates standard inspection methods and criteria for evaluating acceptability of inspection results based on those standards and specifications. Honor specifies in advance inspection related requirements such as inspection items, inspection methods, and acceptability criteria in contract documents. And as a general rule, specifies all requirements in contract documents. Since, however, inspections that need be conducted at different stages of construction involve a wide range of inspection items, it's desirable that studies be conducted in advance on such details as inspection items, inspection methods, timings, frequency, staffing, cost, and required time and agreement to be reached with contractor concerning particularly detailed matters, so that inspections can be conducted in a reliable, efficient, and economical way. If a newly developed construction method or material is used, conventional inspection methods may not be adequate. It's therefore important for honor to draw up an inspection in consultation with contractor. If an inspection has been failed or has failed at a stage of construction, it's necessary either to redo stage of construction or take corrective measures. In this case, it must be confirmed that required performance of concrete structure can be achieved by taking corrective measures. Contractor therefore needs carefully determine construction procedures and details in advance in connection with construction tasks that are difficult to redo. If an inspection has been failed and neither taking corrective measures nor redoing construction is possible, it is necessary to evaluate influence of problems on required performance of concrete structure and take appropriate measures such as demolishing and reconstructing the structure or altering maintenance plan and using existing structure. Inspection records are documents that certify that concrete structure has been constructed in accordance with construction plan and as indicated in design drawings and specifications. Inspection records therefore must be maintained during service period of concrete structure. If an inspection is failed at one or more stages of construction, it's important to record in detail facts including corrective measures taken. Inspection plan. Inspection plans shall specify inspection items, inspection methods. Inspection plan shall specify inspection items, inspection methods, and you can say requirements such as acceptance criteria, timings and frequency of inspection, and staffing. Requirements needed ascertain that structure concerned is being constructed as indicated in design drawings and specifications. Event of any change in design drawings or specifications, inspection plan shall be reviewed. Inspection items, inspection methods, and requirements such as acceptance criteria, and you can say timing and frequency of inspection, and staffing requirements needed ascertain that structure concerned is being constructed as indicated in design drawings and specifications must be determined in specified in inspection plan. That is, standard inspection usually consists of following, that is inspection of quality of concrete materials, inspection of performance of concrete plant, inspection of quality of concrete, inspection of quality of reinforcing materials, inspection of construction, inspection of structure. A series of inspections conducted in a connection with construction of concrete structure includes inspection of materials, concrete and reinforcing bars, conducted to ensure that materials used are appropriate. Inspection of construction conducted mainly to ensure that structure and its members meet dimensional requirements. Specified reinforcement bars have been placed at specified locations. Concrete has been uniformly placed and compacted, and curing has been carried out per requirement. An inspection of concrete structures done after these inspections are passed. It may be just that concrete structure has been constructed per indications in design drawings and specifications. It's desirable that inspection be conducted only for essential items in view of construction efficiency and economy. Inspections that are deemed necessary in order to check whether concrete structure indicated in design drawings and specifications can be constructed must be conducted after their reliability is ascertained. For example, it's thought likely that adequacy of construction when newly applied material or construction methods are used cannot be judged by means of inspections. Through listed above, inspection methods suitable for such materials or construction methods must be adopted in such cases. It's very important to confirm inspection details through in-depth discussion between owners and contractor. Because inspection plan is drawn up on basis of design drawings and specifications, if inspection plan has been changed, it must of course be reviewed. Conduct of inspection. Inspections shall be conducted in accordance with inspection plan. Person responsible for inspection shall judge acceptability of inspection results according to predetermined evaluation criteria. Basically, inspection of a structure must be conducted by owner of a structure on responsibility of owner in accordance with inspection plan. Inspection tasks need be performed under direction of a person who has experience in working in construction work concerned or who has technical experience. If an inspection at a stage of construction has been failed, either construction work concerned is redone or corrective measures taken after discussion between owner and contractor. Inspection methods used after corrective measures are taken must also be technically proven. Reliable methods can say person responsible for inspection must be owner or owner's agent and requires be a senior professional engineer certified by Society of Civil Engineers, consulting engineers, concrete specialist, chief concrete engineer or an equally competent person. Maintenance of inspection records. Inspection records shall be maintained during service period of concrete structure. Inspection records shall be maintained during service period of concrete structures. Inspection records covering necessary items shall be maintained in an appropriate format with reference to maintenance guidance. Inspection records are important records confirming the required performance of a concrete structure. Like design drawings and specifications of inspection plan, therefore inspection records must be maintained. If an inspection has failed and corrective measures have been taken, records regarding their details must be maintained. Because inspection records are important as initial values for maintenance of a newly completed concrete structure, this must be maintained as a source of reference information so that safety, serviceability, etc. of concrete structures can be ascertained. Construction records. Owner of a concrete structure shall maintain construction records during service period of concrete structure. Term construction records here refers to design drawings and specifications including changes, construction plan including changes, inspection plan including changes, and inspection records. It's also good practice to maintain records concerning construction management depending on degree of importance and necessity. These documents contain all information concerning newly constructed concrete structure that can be used as basic data for ensuring required performance of structure during its service period. It's desirable that these documents indicate affiliations, names, etc. of persons who performed relevant tasks. Construction standard. Purpose of its specification, materials and construction standards of standard specifications for concrete structures is to make it possible in concreting work for new construction of an ordinary civil engineering structure to construct a concrete structure of a certain level of quality by carrying out items indicated therein without paying painstaking attention. Prior to commencement of concreting work, it is necessary to fully understand content of design drawings and specifications, prepare an appropriate construction plan. If details such as material use, construction conditions, construction environment, or construction methods deviate from structural conditions indicated in construction standards of this specification, a construction plan consistent with construction general requirements of this specification shall be prepared and construction shall be carried out accordingly. For items indicated in construction, special concretes of this specification should be referred to. Concreting work varies widely because of diverse elements and conditions such as type of structure, materials used, construction conditions, construction environment, and equipment used for construction. It's also true, however, that most of concrete construction projects involve very few special items. Numerous concrete construction projects of this type have already been successfully carried out. In many cases, therefore, it's rational to adopt a construction plan that can be drawn up by making minor modifications to an ordinary construction plan to suit site-specific conditions. Construction standards of this specification is intended for application to such ordinary concrete work as standard guidelines. Construction general requirements, construction standards, and construction special concrete specifications should be used as follows. Construction standards, that is, this document indicates the typical items to be carried out in connection with type of structure, materials used, construction equipment, and construction conditions within range applicable to typical civil engineering construction project. Now, in 2002 editions of construction section of the specification had an independent chapter on inspection. Other chapters dealt with items to be carried out by contractor, while chapter on inspection dealt extensively with items to be carried out by owner of structures. Construction section of current specification therefore has separate volumes: construction standards, inspection standards for construction inspection to clarify responsibilities of each party and make this specification easier to use. Inspections related items to be carried out by constructors, such as items related to receiving of materials, are described in construction standards. Construction standards and construction inspection standards are designed for use as kind of standard specifications for many construction projects. The typical construction work to which construction standards of this specific is applicable involves, for example, specified strength of concrete up to about 60 Newton per meter square, minimum slump at time of placement of 16 centimeter or less, use of agitator trucks for off-site transportation, use of pumps for on-site transportation, over equivalent horizontal pumping distance of about 150 meter or less. So it's very important point here. Minimum slump at time of placement 16 centimeter or less, use of agitator trucks for off-site transportation, use of pumps for on-site transportation, over equivalent horizontal pumping distances of about 150 meter or less, and use of internal vibrators for compaction. Among items related to materials, construction conditions, construction environment, beyond these ranges, those that have been field tested to a certain extent are described in construction special concretes of this specification. It's assumed that in cases where items related to materials, construction conditions, and construction environment beyond these ranges are involved, in cases where special attention is required, or in case where special expertise is to be used effectively, a construction plan is drawn up on a case-by-case basis in accordance with construction general requirements of this specification. Verification is made and then construction is carried out. In all civil engineering construction projects, it's important to draw up an appropriate construction plan according to site-specific conditions prior to commencement of construction. In concreting work, it's necessary to fully understand content of design, drawings and specifications, and draw up an appropriate construction plan prior to commencement of construction, taking into consideration such factors as functionality, strength and durability required of structure and important things to keep in mind in carrying out construction work. As mentioned in explanation above, however, concreting work in most cases consists of combination of more or less standard tasks that include very few special items. Furthermore, in cases where concrete structure is to be constructed has been carefully designed so as to avoid special construction conditions such as excessively dense reinforcement pattern, a sufficient level of quality can usually be achieved by performing standard construction methods management. In such cases, a rational approach is to use items indicated in construction standards of this specification by making minor changes to items. By following procedures described herein, it's not necessary at many construction sites to draw up a special construction plan. Many troubles encountered in connection with construction of concrete structures result from inadequate attention paid to construction at design stage. Designer and constructor therefore need no assumptions made by other party within respective scopes of work. In case of construction ordinary concrete structure, design and construction are usually performed separately. Information is seldom exchanged directly between designer and construction in ordinary project. Therefore, designer needs to perform design tasks with a full understanding of scope of construction standards of this specification. If design tasks also be performed on basis of assumptions that deviate from that scope, it is necessary to clearly indicate it in design drawings and specifications in order to prevent problems at construction stage. When using special materials, production or construction methods that are not covered in construction special concretes of this specification, separate specifications in which provisions on these specifications are appropriately reflected shall be prepared. For reference, following line provides guidelines and manuals dealing with special materials and construction methods published by JSCE. Recommended practice for concrete made by continuous mixer 1986. Recommended for design and construction of reinforced concrete structure using D57 and D64 large diameter threaded reinforcing bars 1992. Recommended practice for concrete containing air entraining and high range water reducing agents. Recommendations for construction of high fluid concrete 1993. Guidelines for construction using blast furnace slag aggregate 1993. Recommendation for design and construction of concrete structures using silica fume in concrete draft 1995. Recommendations for construction of concrete using ferro-nickel slag fine aggregate 1998 Japanese. Recommendation for construction of concrete using copper slag fine aggregate 1998 in Japanese. Recommendation for construction of concrete containing fly ash 1998 Japanese. Recommendation for concrete pumping 2000 Japanese. Recommendation for design and construction of concrete structures using electric arc furnace oxidization slag aggregate 2003. Recommendations for design and construction of reinforced concrete structures using epoxy coated reinforcing steel bars 2003. Recommendations for mixing design and construction of concrete based on leasability 2007. Recommendations for design, fabrication and evaluation of anchorages and joints in raftering and reinforced bars 2007. Recommendations for concrete repair and surface protection of concrete structures 2005. We have many terms in this which we'll go through, and which can go through is not a big deal. These terms are important, people know this, and these are, for example, these terms are in standards, specifications of concrete structures, construction standards are defined as follows, and that point we have to understand very well. And it's of course it's important to know about this and know about that. It's certainly responsible. Terms used in standard specifications of concrete structures, construction standards are defined as follows, and these are very common terms. For example, concrete, mortar, cement paste, plain concrete, reinforced concrete, pre-stressed concrete, aggregate, sieve, fine aggregate, coarse aggregate, sand, gravel, and solid volume, fineness modulus, grading of aggregate, surface moisture of aggregate, maximum size, surface dry state of aggregate, oven dried state. All we have done, and important point is, if required, we'll come back to the problem. We'll review once more. Now it's saying is that reinforced concrete in a wide range, wide sense also includes pre-stressed concrete, steel framed reinforced concrete, in which hot rolled section steel and shapes are used as reinforcing material. However, this specification term refers to concrete containing reinforcing steel. And sieve, we know very well what sieve is, standard sieves for concrete, as you know, sieve, standard sieves, we all know that. And fine aggregate, coarse aggregate, distinction between fine aggregate and coarse aggregate is quite freely decided and has no theoretical grounds. These depend on examples of calculation of fineness modulus, which we have already seen that one. Already we have constant grading of aggregate fineness modulus, we have gone through all this. So don't waste your time on this, just move on further. And of course, reinforcing bars and deformed bars, we have defined all we have defined, and particular reinforcing bars of wide sense reinforcing include all kinds of steel bars embedded in concrete to reinforce concrete. However, generally it means steel bars for reinforced concrete specified in this steel bars with equivalent quality is shown. This specification makes it rules to use only steel bars that conform to GIS, except those conform reducible by a test. So deformed bars are there, which I have gone through, and mixed proportion, all this well. Characteristics, compressive strength of concrete, and we should know, all know, but let me repeat this. In this specification, compressive strength of cylindrical specimen is used. Compressive strength of cylindrical specimen is used as standard one to represent strength and quantity of concrete. Generally, characteristic compressive strength is determined on basis of compressive strength 28 days. Compressive strength of concrete varies to a certain degree according to quality of materials, construction conditions. Therefore, mixed proportions strength shall be determined on conditions, probability. Its probability of being equal to or higher than characteristics compressive strength is higher than a predetermined margin in case where design is based on tensile strength or flexural strength of concrete. Characteristic tensile strength or characteristic flexural strength is used. In case where design is based on strength of specimens tested at 91 days or 7 days, strength is called characteristic strength at 91 days or 7 days respectively. However, characteristic strength generally implies strength at 28 days. Mixed proportioning strength is desired strength to determine mixed proportion of concrete. It's obtained by multiplying characteristics compressive strength to over design factor, taking into account variation in quality of concrete. And unit content, termed unit content, is used for making short quantity of specific constituent materials used for producing 1 cubic meter of concrete or mortar. Unit cement content C, unit water content W, unit content of aggregate, unit content of fine aggregate S, that is unit content of coarse aggregate G, unit content of air entering agent, unit content of pozzolana, and so on, and use powdery material content and cementitious material content. Powdery material content is total of unit content of different powdery materials including cement and other cementitious materials and admixtures, and is regarded as a major indicator of segregation resistance. Cementitious material content and cement content may be thought to as indicators used to evaluate strength development properties, heat of hydration, and durability. Mixed cement may be described, strictly speaking, as a binder, but it's conventional practice to classify mixed cement as cement, and term cement content may be used. Powdery material is cement and binder and powdery material. Definition of powdery material, binder, and cement. Slump is measured in accordance with this GIS A 1101. Although concept of minimum slump at time of placement is indicated in construction standards of this specification, unless otherwise specified herein, term slump is construed to mean average of measured slump. Consistency and workability. Consistency is an important fact of workability and can be measured fairly accurately by slump test. Although many testing methods for measuring workability were studied and proposed in past, there are no testing methods universally adoptable in field. Therefore, workability suitable for work needs to be judged by an expert slump test. And slump test is efficiently used as a supplementary means of judging workability of concrete. Pumpability factor. Determining pumpability includes the ability to achieve a high pumping rate under a light pumping load and ability to resist clogging of concrete piping. Placing height and compaction height. In conventional concreting projects, placing height for each layer or lift of concrete is specified, but placeability varies widely depending on how compaction is done. Construction standards of this specification therefore defines new term compaction height to distinguish it from placing height. For example, to place concrete for wall members or columns members in a typical project, workers net enter concrete forms and perform compaction depending on member sizes and reinforcement patterns. However, this method of compaction may be difficult to perform, and placing height per layer or equivalent lifting differs from compaction height. And durability. Well, this is just durability, which is a very important point. And durability, let's level it. Durability, external actions which adversely affect the durability of concrete. That is, external actions which adversely affect durability of concrete include freezing and thawing action, attack by chemical substances, and rubbing action. Furthermore, when material of poor quality are used, long-term stability of concrete is deteriorated. In case of members of reinforced concrete and pre-stressed concrete, corrosion of embedded steel progresses and their durability is damaged. If their concrete is neutralized or chloride is accumulated beyond a certain limit in members. Alkali aggregate reaction. Alkali aggregate reaction is classified broadly into alkali silica reaction and alkali carbonate reaction, depending on kind of mineral substance which reacts with alkali, but most of reported cases of alkali aggregate reaction in Japan are alkali silica reaction, When alkali silica reaction occurs, cracks develop in concrete because resulting alkali silica gel swells when absorbing water. Freeze thaw reaction, piezo resistance. When concrete when concrete and or aggregate particles containing water are frozen, expansive pressure develops due to freezing of free water inside these materials. Freezing and thawing action induces slack off or damage in structure of materials due to expansive pressure. The degree of damage increases with repetition of freezing and thawing action. Entrained air in concrete plays a role of relieving expansive pressure during freezing of concrete. Crack resistance, very difficult to avoid cracks, but controlling number of cracks and crack width is comparatively simple. Controlling crack is very important as long as durability of concrete, water tightness and its appearance are concerned. Cracks may be induced by many causes, but it's possible to improve crack resistance by properly selecting materials, mix, proportions, construction method. In addition, inappropriate design of concrete surface is also very effective in crack controlling. Inspection is carried out on qualities of material, concrete construction processes and constructed structure using various inspection systems. Generally, inspection of material and product is carried out by purchaser. In many cases, structure owner just confirms inspecting results based on inspecting records afterwards. In case of ready-mix concrete, constructor usually carries out inspection because they purchase materials. However, designated inspector usually carries out inspection because they purchase materials. However, designated inspector often carries out inspection when ready-mix concrete is used. Inspections during construction or at completion are commonly carried out by structure owners. Now, how much we have here? Let me see. It's only a few minutes more. Okay, so we can just talk a little more. And here is we say moist curing, temperature control curing, and accelerated curing. Moist curing is to ensure that necessary amount of water for hydration of cement in concrete, since it is not sufficient just by preventing evaporation of water from placed concrete. This curing method is also effective in preventing cracking done due to drying shrinkage during initial hardening. So I repeat, moist curing is to ensure necessary amount of water for hydration of cement in concrete, since not sufficient just by preventing evaporation of water from placed concrete. This curing method is also effective in preventing cracking due to drying shrinkage during initial hardening stage. Temperature control curing method is to control temperature in each part of concrete to facilitate normal hardening process and to avoid cracking after hardening, as well as and development of excessive internal stress. In utilizing this curing method, it's necessary to take into account both sides of members and effect of construction conditions. Accelerated curing, some curing methods to accelerate hardening rate of concrete, such as steam curing, autoclave curing, hot water curing, electrical curing, infrared curing, and high frequency curing. However, in general, steam curing is widely used. So what accelerated curing is? Some curing methods to accelerate hardened rate of curing, rate of concrete, such as steam curing, autoclave curing, hot water curing, electrical curing, infrared curing, and high frequency curing. However, in general, steam curing is widely used. Quality of concrete. So I have to see here now. We have to go through all these specifications and we have to respect to time. respect time also here, and the specifications here, we can say here that we have to think of each and every issue. It says here, you can see, I remind you of my email, and you can see that suraj_engineer@yahoo.co.uk, and this is my reminder of certification. This is quality file we had held here, and we'll continue from here. And coordination, engineering and concrete, as we're discussing quality of control, quality of concrete, and we have to go through this point efficiently, whatever may happen. And we can say that this file, quality file, it's very important, and quality and coordination in concrete. So we can say we have to go through. The purpose of this talk was that we have to think of concrete in a manner it should be. It was not taken for granted, and we have to take it for granted. No, not at all. We have to take it for constructive means. Its job, it's concrete. It's not something to eat. This material which we are talking of shall stay with you maybe for many decades. It's not just 6 months or 1 year or 2 years product you buy from market and you are happy, but it's something that is your friend, that is your family member forever, and you want to see your friend, your family member, weak one or non-quality, and that's what you have to spend money and decide. It's not ordinary amount. You get a house of for many millions rupees you pay, if not millions, at least 1 million you have to pay, and that is for your future. And if you think, no, I don't, I just want to invest money and make money after disposing it, it's different attitude, but you're not, I don't think that's the right attitude. And it should be done positively and clearly. That's what the point is. Our purpose was for quality and coordination and engineering projects works, and you can say communication importance, and this is a part of communication I'm saying now. Coordination, I'm trying to teach what coordination is. I'm trying to represent what coordination is, because it's very important one. So concrete, we have discussing a concrete specific particle. Japan first time trying to impose on us. It's also telling something. This for this yeah. So we have here, contracts. Contracts, I could not go into details, but it's very important item. Contracts, which is root of work, and contractor, as we said many times, contractor has to do this and contractor has to do that, and that is what contractor has to do. Complete responsibility of construction. If it's EPC, then design's responsibility also goes to contractor, and you cannot take it for granted. So think here what contractor is. Contractor is a professional organization. It's a professional, in fact, because contractor has to take responsibility and reliability, and that according to international world organization. But I don't know what most people think here about responsibility. Contractor is a professional. Contractor is given the job of profession. It's not only job, it's engineering contract, engineering work you have to do. It may include designs, it may include designs, but construction definitely is going to include the procurement, and you have to involve yourself for long time in this project, on this project, to get more opportunity. At that time doesn't come always there. There's a problem is. We have to go through all these requirements of contracts. We have to understand them. In this talk, I could not continue on that, but it's very important that we have to see contracts, and if there's violation of contract conditions by either party, there should be some disputes, payment disputes, work dispute, or some other disputes, quality disputes, which must be taken care of by someone. And there are provisions in FIDIC also. If you see this, there's FIDIC is standard-wise one. There's a provision of engineer, there's a provision of DAB, there's a provision of arbitration, and that's an important point. We have to go into that, and that depends on because we are talking of concrete and we are talking of materials, and concrete is very important and it's very expensive, and of course thousands of cubic meter of concrete are used on each project, and that's why the chances of disputes and contextual misunderstanding of contextual relevance, and that's what means it's important to go into in-depth studies of existing contract or valid contracts. If you have to reach problem, it's the arbitration exercise to understand this perfectly. Otherwise, maybe you don't listen to people that don't listen to me. At least that can happen. I should not say that no, it can't happen. It will happen, and that think about this in every way possible. Every perfect. So hold on a minute. I'll come back with this. Hold on a minute, please. I'll be back. So I'll take your leave now because it's too late. Of course it's Saturday, but you people have also some works. I take your leave now. It's already 3 minutes time. So thank you very much. I think let's say we can check this, and we'll be back on page 60. I will say somewhere 65. We'll be back, and I hope you enjoyed this. Again, I say my email ID is suraj_engineer@yahoo.co.uk. If you want to write, you are most welcome. And phone number is also there, but I'm not going to say phone number because it disturbs, and you want to write some question, this question. I want to write some, to suggest something, and suggest something also. It's your greatness. If you can do that, thank you very much.